Okay. Open up already. Yeah. And we go to this frame. Yeah. Explaining about endothermic and exothermic reaction. Okay. Basically, these energetics are talking about energy transfer between system. And what is meant by system is the chemical substance. That's a system. Yeah. And anything outside the system, you call it surrounding or environment. Yeah. Okay. If energy is transferred from system to the environment, this process is called exothermic or endothermic.
Exothermic.
Very good. And in chemistry, we take the point of view of the chemicals. Yeah. Exo means out. The energy is transferred out from system. Then the delta H is positive or negative?
Negative.
Because we take the point of view of the system. The system is losing heat energy. Yeah. Then the opposite here. If you receive heat energy from environment to system, this process is called something?
Endothermic.
And delta H is positive. That means the system is receiving. Now, what is meant by system? System is the chemicals. Yeah. Let's say you have a beaker. Make it smaller first. No, not smaller. Like this, yeah. And on beaker, you pour water. Then you are reacting to things. You're putting in sodium hydroxide and HCl here. Will they react? Yes, they will react. What type of reaction here?
Neutralization.
Very good. Will it be exothermic or endothermic?
Exothermic.
Very good. So you will produce heat. And when you do this experiment, you're using a thermometer here. Then you do it. You put everything on the table here. And this is you doing the experiment. Yeah, watching here. So which one is the system? Is the water system or environment? This water in the beaker.
The water. Wait, can you repeat the question?
You're doing this experiment, and every object in this universe, you can put it under two categories: system or environment. So the focus today is this experiment that you're doing in the laboratory. Yeah. So every object, the water, the NaOH, the thermometer, the beaker, the table, you yourself, you must be able to tell who is system and who is the environment. So the water itself is
System.
System is the chemicals. The NaOH,
Surrounding.
system.
System. Oh, it's like everything inside the beaker is the system.
Yes. The beaker itself.
Surrounding.
Surrounding, correct? The
Environment.
thermometer, yeah, environment, yeah.
Environment.
Yeah, environment, yeah. The thermometer,
Environment.
environment. The table,
Environment.
good. You yourself,
Environment.
yeah, good, yeah. So that's it, yeah. This is if you're doing the experiment for a solution. If you're doing the experiment on for gas container, gas chamber, the container itself will be environment. Yeah. The system itself is the gas inside. Yeah. The container is the environment. Yes. So you have exothermic reaction and endothermic reaction. Yeah, and the way you write down the delta H is on the right side, right after the reaction, then you put delta H equals to some number. And the unit is usually kilojoule per mole. Yeah. So later when you do calculation, don't forget to convert that kilojoule into joules. Yeah, if you're using joules. This thing, this is per mole. Understand? That number is per mole. That means what they're saying here, if you're reacting 1 mole of C8H18, you will produce 5512 kilojoule. Yeah. Okay. But if I change the question, if you produce 1 mole of CO2, how much energy you produce?
5512 divided by 8.
Correct. Yes. So you must take care of the coefficient here. Yeah. What if the reaction produced 18 mole of H2O?
Well, I couldn't hear you.
What if the question asks about the energy produced to produce 18 mole of H2O?
5512 times 2.
Okay, good. That means you understand. Yeah. So you must write down the delta H on the right side, right after the reaction. Yes. This is example of physical process. This is not chemical process. Yeah. You just heat up the sodium until it turns into gas. So you calculate the delta H. Yeah. Okay. So that's the first part. Yeah, the calculate the delta H.